I'm Eduardo from the Federal University of Technology in Paraná State, Brazil. Due to health issues, I decided not to travel to Australia to attend this conference, and I was allowed to make a recording of my presentation. Presentation is about dynamic measurements that could be done in developing countries. So we developed a backpack, which is low cost for field studies in human biometeorology. The team is composed of me, Solange, which is a researcher from the northern part of Brazil, Paraíba, a master's student, Walter Ihlenfeld, and a PhD student, Linccon Carvalho. The rationale behind this study is based on the measurements or the need for taking measurements and understanding urban climate issues in developing countries, and also to allow low-budget research to be conducted in this area. So we asked three basic questions before we started anything on this project. The three basic questions guiding the elaboration of research proposals, as you might know, are the what, the why, and the how. And the three questions guiding the presentation of the PLAMS project, and I'm talking about the PLAMS later on, is what we develop, why is it low cost, and what for. So in this presentation, I'm showing you the three questions answered. So what did we do? What did we develop? We developed a portable low-cost environmental monitoring system. The acronym is PLAMS, and it's composed of several sensors, low-cost sensors, connected to a microprocessor. And the device costs very little, so it costs within the price range of $250. Here you can see the images showing the hardware, the microprocessor, and also some other devices connected to it, as the power bank and the micro SD logger. We also have the sensors comprising of thermal sensors, humidity sensors, wind speed, and also urban noise that we wanted to investigate, and CO2 sensor. We have also the casing, the shield, and globe that we developed for this project. You can see the images showing the backpack as it is, and here attached to a person. The main features here are, it is an Arduino-based system. The language we used was C++, and the basic scheme is shown. So you can see here the many parts connected to the microprocessor. Later on, after my presentation, I will show you a short video with the device. For doing this, we first developed a validation step. So we compared the device to a more robust equipment, which was new and factory calibrated. We had this equipment exposed to the environment of a climate chamber. And we had several measurements here, like air temperature and humidity and globe temperature, and in this case, the ventilation. We also have here the question of why. So why low cost? We had some financial constraints. Funding sources are presently scarce in Brazil, so the federal funding is practically not available, and purchasing equipment is rarely allowed in internal funds from the university. So there is limited funds available mostly for maintenance, services, and consumables. And worldwide, if we think about the application of this worldwide, there is an ever-increasing urbanization trends in the developing countries, and the climate change impacts are harsher in developing countries. And also there is an urge for OTC, outdoor thermal comfort research, in such countries. Another possibility is to launch low-budget research initiatives, such as this one, to use open-source electronic platforms and user-friendly and flexible devices. And also the whole project is aimed at citizen science, allowing people or small groups of researchers to study the urban climate phenomena in detail, and then to have a possibility of crowdsourcing with participatory monitoring. If you want to see more about this, there is a publication here, and you can use the QR code for getting access to it. It was published this year in IJBM. The three questions about the why low cost. We have several products that we are developing in my lab such as the climate chambers, and also we have several studies using test cells. We developed a newly also heating and cooling device with passive means, and there's another project here on the shading device that we are also testing. And here's the, let's say, the cousin of PLAMS, which is a small unit for measuring comfort-related variables. And it's very small, and can use this in labs or offices. And what for? So the question is what for? What do we need the PLAMS for? We performed some tests, some studies. First, the initial test was to see if it's stable enough, if someone can carry without any burden. The second study here, which is here called the first study, is the urban transect. So we conducted urban transect in this area here to the left with several points, altogether 12 points, with different Skyview factors. And this lady here is a PhD student, and she's walking around with the backpack and stopping at those points and taking measurements of the thermal environment. You can see here the relation here between the points in terms of the Skyview factor. And here we also tested whether the system was able to capture the, let's say, urban signal from the different points. And looking at the graph to your left, you can see the temperature. It's not quite linear if you go along the points. But if you have a stable equipment, which was stationary on top of this building here to the right side, you see that there is a very visible difference between both in terms of temperature and relative humidity. We also did some calibration of a simulation model with EnviMet. So here you see the same area, and also we have the model here. We tested the measurements in terms of calibration and validation of our EnviMet model. And we compared one point only against several points, a network of points, and to see if the dynamic measurements make more sense than to take one single measurement and calibrate a simulation model. And you can see here in those graphs that for the stationary measurement, which is here to the left, there are some discrepancies noticed between simulated model and the actual condition. And in our dynamic measurements, the lines are pretty much the same. So here comparing temperature against temperature, measured and simulated. And there is surely a gap between both. So there is an overestimation of thermal temperature in EnviMet. But nevertheless, you can see they follow the same pattern. Another study that we conducted is on the OTC campaigns, so that you're investigating here outdoor thermal comfort. And we had also a circuit here that should be covered in less than 1 hour, 40 minutes, so about 40 to 50 minutes. And we had a questionnaire. This questionnaire was actually a Google form. The students could get access to it with their cell phones. And we walked around the area here, stopping at those points for 3 minutes, collecting data, and then later interpreting this such data in terms of the Skyview factor and other features. And here you see the difference between the 5 points that we had in this record, in this group, and the differences, they are quite visible without too many differences between them. Another study is being conducted in the Northeast by the group of Solange, which is my colleague, and she's conducting the same kind of campaigns with the backpack. It's the same unit that we had here. So she developed together with Walter here in our university. They came up with a similar plans for the Northeast. And the students is taking some participants to cover a circuit of a park. So it's a predefined route throughout this entire park in the Northeast of Brazil. Other applications possible for the system that we can envisage are for thermal mapping, and this is another step that we want to cover. And also we have the acoustic measurements that we can also develop the acoustic map for the area that we explore. We can test also the effect of different spots on air quality with our CO2 sensor, and light intensity, which is also something that we're measuring with the device. And finally, you can also, there was an idea that was presented to us last week, that we could investigate and monitor the microclimate of migrating populations. In this case, the person who talked to us, she was interested in insects that were moving to one group of trees to another, and we could follow them, taking dynamic measurements in this case. I would say thanks for listening, but please stay on for the short video we're presenting afterwards. I would also give my acknowledgements to the WMO for the travel grant, but unfortunately, as I said, I couldn't travel. Thank you.
Dear friends and followers,